Yeah, welcome to the Tech Talk by Testo Saveris. So we would like to introduce to you how smart food safety solutions also have an impact on sustainability, integrity, and efficiency. So my name is Stephanie. I am a nutritional scientist, and I'm also a food safety application expert for Testo Solutions. And this is my colleague.
Yeah, hi, I'm David. I'm a product manager at Testo, working to improve and develop the next level of digital food safety management systems.
Okay, so food safety solutions, that's really a broad field. So in this Tech Talk, we would like to focus on ambient temperature monitoring, which is an essential part of food safety solutions. And it's necessary, we all know that, but with the collecting of data, we really create a flood of information, and the vast majority of this data is not critical. And it's assumed that more than 90% of the data is non-critical. 90% of the data we collect with monitoring is non-critical. That's really a big number, David, right?
That is. And now imagine that people actually act based on this uncritical data. There is actually a lot of work being done. It's quite inefficient. And it's also the case that improper handling of temperature alarms can contribute significantly to food waste, because people maybe throw away and discard product that was okay, which is a crucial economic and also environmental impact, of course.
And it's not only regarding environmental impact or economical impact, it's also regarding the food safety, a big impact. So in general, ambient temperature monitoring, it's really necessary, and it gives the basis for exception-based monitoring, and we receive immediate alarms in case of deviations, but there are some drawbacks. So if we do not correctly classify the data, then we can really not good understand what we are talking about. And I like this sentence: ambient temperature is not equal to product temperature, and product temperature is actually the thing what we're looking for. So if you're not correctly classifying the data, we create a lot of useless data, for example, false alarms through ambient temperature spikes, and we cannot distinguish between critical and non-critical data. And ultimately, and I think that's particularly crucial, that the advantages of temperature monitoring, they can really turn into disadvantages and really jeopardize the food safety culture through alarm fatigue. So alarm fatigue, you know this, that people really overlook the critical alarms because they're just overwhelmed by the flood of information. And so they will not focus on the real critical parts anymore. They're just annoyed. And even beyond food safety, which is for sure the core, we cannot use this data to optimize processes, for example, to reduce food waste as well.
Yeah. So maybe let's look at how this actually looks in practice. We've brought here an example from a Swiss supermarket chain where we have done this demo, this test. And we brought a graph of a temperature in a freezer, cooling ice cream over the course of 7 days. And what we can see is that the temperature tends to fluctuate quite a lot here, the ambient temperature in the freezer.
And just a question, David, because you're just telling this, but where do these fluctuations come from?
Yeah, these fluctuations can have multiple reasons, of course. One being, if you're in a retail environment, the opening and closing, of course, of the consumers actually buying a product, but also defrosting cycles. Defrosting cycles in equipment are a major cause for these spikes, and that's also what we can see here quite a lot. And we can see if we would have alarmed here based on the air temperature, there would have been a lot of alerts. And the product, which we can see in dark blue, which we actually measured with a different logger with a core temperature measurement, so a real core temperature measurement of the product, was only above the threshold 3 times, only for a brief period of time, and only just ever so slightly, so not really that much of a food safety risk in this case. That's what we see here. And maybe also another example, which might be even worse for food safety, and this is not an example from inside a store, luckily, that's a power outage. We have a 12-hour power outage simulated here, outside of operation hours. So power goes out when there's no one in the store and resumes back when there's actually, or before there's actually people there again. And what we can clearly see is the air temperature goes up quite a lot above the threshold, and the product follows with a delay, of course, because of the thermal behavior of the product, but it does go above the limit. In the morning, when the power resumes, the equipment typically tends to cool down very, very quickly. If you're talking about a freezer in a kitchen, it's typically below the threshold within like an hour. But of course, the product is very warm at that point in time, and it doesn't cool down as quickly because of the thermal inertia that it actually has. And that's something that, imagine now someone goes into the store, power has come back, and they just look at the display of the temperature on the freezer, and they don't have the history of the alarm of what happens. They might actually decide that a product is safe to use and safe to consume, but the product is actually 20, 30 Fahrenheit off.
So what can we do to handle all these risks, David?
Yeah, and the answer is pretty clear. We need to have a risk-based approach to temperature alert timing. And we do that with product simulation.
Let's have a look at product simulation.
Yeah, what is actually product simulation? We take, based on the air temperature that we can see here, and we put that into an advanced algorithm, and we basically get this. We get the simulation of the product core temperature, and that allows us to do several things. It gives us, first of all, a continuous view on the product. So we can look into the system, and based on the IoT data we have, see how the product actually behaves. And it enables us to do alarming in case of product deviation, not ambient deviation. So with that, it basically enables a real exception-based management and not an exception-based management based on things that aren't really bad for the product.
One point, I think this is in theory, this sounds very interesting, but how reliable is this data?
Yeah, that's actually a very valid point, and let's maybe look at the exact examples we had before. So the example from the Swiss supermarket, in orange we have now added our simulation. And what's important is the simulation is calculated based on the air temperature. So the simulation does not know the product core temperature that we measured here in blue. And we can see the curves follow very, very closely. The deviation is well below sensor tolerance. And that enables us to not look at these alarms we have here of the air, but actually only look at the places in time where the simulation and the product was above the thresholds. Basically, in this case, we reduced total alarms by 67%, which is not quite the 90% that we heard about earlier, but we reduced false alarms by 100%, which is the crucial part here. So there's nobody acting anymore when the product is actually not in jeopardy. Let's maybe also have a look at the 12-hour power outage that we had before, because this is also very critical and a risk for food safety. And there's actually two things that we can do here with product simulation. And that's, first of all, what we call the action zone. When a product goes out of range or goes above the threshold where it's supposed to be, according to the FDA food code, for TCS foods, you have roughly 4 hours to actually do something with the food. So process it, cool it back down. And this is really crucial to know when the time is when your food and your product went above the threshold to actually optimize and leverage the full window that you have here. So to use this full window of opportunity, allowing you to reduce food waste and optimize usage. And maybe even more critical is what we talked about earlier with people actually not knowing the real state of the product, which we call in this case the invisible zone. If you don't look at product temperature and don't simulate it, well, yes, you can go ahead and measure it with a handheld measurement, the core temperature of the product. But if you only look at the display on the equipment, you might actually have the false opinion that you don't even need to measure if you didn't have an alarming. So product simulation in this case really uncovers the blind spot, and it allows you to see things automatically that you would have not been able to see if you're only looking at the air.
Yeah, thank you, David. Great example, which shows as a practical example how technology can help to make the invisible visible and to derive the targeted actions to the truly critical points. And I think this really thrills me the most with the action zone and the invisible zone. And it shows that this is, with technology, possible to really reduce significantly alarm fatigue and to identify the genuine risks rather than just trigger unnecessary alarms and allow our staff to focus on the critical points while maintaining operational efficiency. And what I think is mostly important is that here we see that technology really helps to strengthen the food safety culture in an organization. And if you would like to learn more about the IoT sensors, product simulation, ambient temperature monitoring, this is part of our food solution. Happy to welcome you at our booth, which is right next to the espresso bar. Thank you so much.
Thank you.